Okay? So all you have to do is just find one counterexample, some string that is greater or equal to this pumping length, that is not pumpable. Right? In other words, that it does not belong to the language, one of those three conditions, it does not apply to the pumped string. You only have to find one string that does not satisfy all three of those conditions, and a disproof of any theorem is when you only have to find one counterexample. Okay? As I was saying before, right? So you find one counterexample, and that'll give you a contradiction. All right. Here's a sort of formal statement. The pumping lemma. The pumping lemma guarantees the existence of a pumping length p. Okay? So the pumping lemma says that it is a pumping length little p, so that all strings of length greater or equal to that little p can be pumped. Meaning, this belongs to the language. The size of y is positive, and the size of x, y is less or equal to p. Those three conditions. Right. All right. Now, so what you need to obtain the contradiction, all you have to do is just find a single string, okay, whose length is greater or equal to p, pumping length, and if the language were regular, that string s would be pumpable, right? Because that's what the pumping lemma says. It says if the language is regular, then every string will be pumpable. So if you can just find one that whose length is greater or equal to p, that is not pumpable, well, you found a counterexample, and therefore your initial assumption that the language was regular, well, that's false. Therefore, your language is non-regular. Right? That's what this is saying. Okay. Now, so you found a string s that cannot be pumped. Let's say. Okay. Now that's not enough. You need to do a bit more. You need to show that. In showing that s cannot be pumped, you need to consider all the various ways of dividing s into these three substrings, x, y, and z. Okay, and in this case, using condition 3 can be useful. You'll see in later examples that condition 3 gets used quite a bit, and without it, you'd have problems. The first two conditions are not sufficient to give you a counterexample. So without condition 3, you might be coming to the wrong conclusions. You may be thinking that this particular string s that you're trying to use to obtain a contradiction, in other words, you're trying to show that this string s is not pumpable, but you're finding that it is pumpable unless you use condition 3, and then using condition 3, you find that string s is not pumpable. Okay, so condition 3 quite important, as you'll see in future sessions when we go through these 5 examples of using proof by contradiction to show that a particular language is not regular. Right. All right. So going through the various ways of splitting up x, y, and z, the various categories, and you need to go through. Now this is a bit vague at the moment, but as we go through the examples, you'll see examples of how it's done. you need to consider all possible cases of your possible pumped X, Y, and Z for different values of I, for what your this middle pumped. There are various ways, various families, categories of pumped values you can have. That's a bit vague. Like I say, that will become clearer as we actually do examples. So, okay. So if you can find an S whose length is greater or equal to the pumping length, and you can show by doing all these cases that that string S cannot be pumped, well, you found yourself a counterexample, and therefore your language B, by proof by contradiction, therefore your language B cannot be regular. Okay. Okay. Now a comment here, sort of a little bit of advice. You're trying to find a string. Now you're trying to find one counterexample, right? Proof by contradiction. You only need one counterexample. Now, choosing as a candidate string S to use as your counterexample, that can be quite creative. It may not obvious. You may choose an S that turns out to be pumpable. So you may have chosen the wrong one. So don't give up. Just choose. I mean, if you're really convinced that a particular language is non-regular, then you choose a particular S that you think is a good choice, but you find in practice that it is pumpable, then well, I guess you've got two options. One, you've chosen the wrong S, so you need to choose a different one in the same language, and that new one may end up being non-pumpable or unpumpable, if you like, in which case you've proven that your language is not regular. Another option, of course, is that your hunch about the language itself might be wrong. Maybe that language is regular, in which case all your strings greater than this size will be pumpable, because that's what the pumping lemma says. All of them of the appropriate size will be pumpable, and we prove that. Okay, so the art, I suppose, of choosing an appropriate candidate string S that you're going to try to use as a counterexample. Choosing the right one is a bit of an art. So try to, a bit of advice here, try to use a string that you feel reflects the very essence, the main reason why you think the language is non-regular. Try to find in your head a clear example of a string that reflects that suspicion, that strong suspicion that you have that the language is not regular. So try to choose a string that would have that property that makes the whole language non-regular, right? In other words, makes the string, at least one string in that language, non-pumpable. You only need one, right? That's the nature of pure math. To disprove something, you only need one counterexample, because to be a proof, has to show in all cases that the assertion, the statement in the proof is true. It's true. It's true in all cases. That's what a proof is. So to disprove it, you only need to find one counterexample. All right. Okay. So the next two sessions, we will do about 2.5 examples of 5. Right, so quite a few examples on this topic. We will use proof by contradiction. We will use the pumping lemma to perform that proof by contradiction. and we will show in 5 cases that 5 particular languages are not regular. Okay, so that will be for next session.